Hello, in this lecture recording we are going to take all of the data for Glickman Electronics and we are going to put it into Microsoft Excel. Then we're going to use the solver function to use the simplex method of linear programming and solve the problem. I will walk you through how to install the solver add-on, and then we will also do the very first Glickman Electronics example together in Microsoft Excel. I will explain what all of the outputs of what we're about to do in Microsoft Excel. I'll explain what they actually mean in a different lecture recording, but this one I wanted to walk you through the technical aspect of getting linear programming, the solver feature added into Microsoft Excel, and then adding Glickman Electronics into Excel so that you can actually solve the problem, and then what it all means we'll talk about later. Okay, so you can use Microsoft Excel and the simplex method to solve linear programming. You need to add the solver add-on so that you can do these problems. You do not need Palm. Microsoft Excel will work just fine. Okay, so for Glickman Electronics, we're going to start with Glickman Electronics. If you recall from the last video, our decision variables are the x1 and the x2. That is our xpods and our blueberries. So that's how many we're trying to determine how many of each product to make. Our objective function is to maximize profit, and it's subject to the constraints of 240 hours available per week of the electronic area and 100 hours per week in assembly. So we're going to take that data and we're going to put it into Microsoft Excel. So you can see we've got our decision variables of x1, x2, our objective function of maximizing profit of max z equals 7x1 plus 5x2, subject to our constraints, which are the electronic constraint and the assembly constraint, and we will put that all into Microsoft Excel together. So if you open up Microsoft Excel, we can do it real quick, and we can do it together. Okay, so I have taken the liberty to add all of the Glickman Electronics information into Microsoft Excel. If I were you, I would copy everything down exactly how I have it, including the rows and the columns, so that you can just copy my formula exactly. Okay, you can copy my formula exactly. So for your objective function, I would put your very first, I would put the objective function into row B4 and C4. So you can see that your xpods make $7 of profit per unit. Your blueberries make $5 of profit per unit. And then you've got your left and your left-hand side and your right-hand side constraints. This is what we talked about earlier in regards to the left-hand side and the right-hand side. I said it would make a little bit more sense. And you'll see as we put these into Solver how we are going to walk through them step by step and how they will calculate out the simplex method and your linear programming answer after we put all this data into Excel. So you can see I've got your formula for your objective function as B4 multiplied by B8 plus C4 multiplied by C8. So B4 is your xpod, and your solution value is down here. It's going to be 0 for now. Your blueberries, your objective function is $5 per profit per blueberry, and your solution value is 0 for now. Now, when you type in this formula into the left-hand side the very first time, what you're going to get is 0, okay? Because it's going to do that math, and it's going to type in 0. You need to press Control and then tilde, okay? The tilde is that squiggly line. So when you press Control tilde, it's going to open up your spreadsheet, and it will show these three formulas, okay? So you're going to copy each one of these formulas as I have them. Your electronics is the next formula. Your left-hand side is subject to the constraints, which were that it takes 4 hours per xpod in the electronics area. It takes 3 hours per blueberry in the electronics area. You can see in column E, we've got less than or equal to your right-hand side constraint, which is the 240 hours available. So you cannot use more than 240 hours. You've only got 240 hours available. Then we go down to assembly. An assembly is simply your 2 hours per XPod and 1 hour per blueberry. You're going to multiply 2 by 0 plus C6, which is 1, multiplied by 0. And when we do the add-on of the solver function, these numbers will eventually change. Okay, so that is all the data that you input for Glickman Electronics. Copy this exactly like I have it, and then make sure you do Control tilde so that everything opens up and you can see your formulas. Now, even though I do this every few months, for some odd reason, solver always seems to drop off. So I am going to walk you through now how to add solver to the Data tab in Microsoft Excel. So to add solver in Microsoft Excel, you can add it by going to Select File, Excel Options, Add-ins, and then Add Solver. And that's how you do it for PCs. I don't have a Mac, so I can't validate that the information that's provided below is accurate. So if you are a Mac user and you try and install solver following these instructions and it doesn't work, please let me know and I will update my PowerPoint for future Mac users. But I do know that it works for those of us that have PCs. So again, it's pretty simple. We're just going to go to Select File, Excel Options, Add-ins, and Solver. So what that looks like, depending on the version of Microsoft Excel that you have, you go to File, you go to Add-ins. After you go to Add-ins, another screen will pop up. You click Solver Add-in, then hit Go. It will ask you again for the solver add-in, and then you click OK. Then, when you go to the Data tab, you will see solver on the far right-hand side. All right, now let's do this together. So I'm going to go to File, Options, Add-ins. There's the solver add-in. So I'm going to click OK. Sorry, I'm going to click Go. And then the solver add-in and click OK. You can see Microsoft is thinking for a second there. Now I'm going to go and check on my Data tab to see that it's there. Now I'm going to move my face so that you can see solver is there. And it is, so that's good. Here is solver on the top right-hand side. So we now have solver installed into Microsoft Excel. Okay, so now we have installed solver into Microsoft Excel, and what are we going to do with it? So I'm going to walk you through really quickly the steps that we will do in Microsoft Excel for Glickman Electronics. So the very first thing you do is we add our objective function. And again, if you copy down the spreadsheet exactly like I showed you, all of your numbers will also align with what's in the PowerPoint. So you will go to the D4, which is where your left-hand side, that's your objective function. You're going to type that into the very top, which is your objective function. Next, we're going to put in whether it's a maximum or a minimum. And in this case, with Glickman, we're trying to maximize profits. So we will click Max. Next, we're going to add our decision variables. And our decision variables are those two zeros that we have down at the bottom. You will hold cell B8 and drag it over to C8, and that's your decision variables. Next, we will add our constraints. Constraints is the only tricky one. You have to add in your left-hand side constraint. Then you make sure that your greater than or equal to is the same. And then you add in your right-hand side constraint, which is in this case 240 for electronics and 100 for assembly. You will click Add twice before you click OK. It's not a big deal if you go out of order. You can always go back and add more constraints, but it's easier if you just do it right the first time and click Add instead of OK. Next, you will make sure that this button is clicked, which is Make Unconstrained Variables Non-Negative. Another fancy way of saying make it all positive. And then you make sure that you are clicking on the Simplex Linear Programming Method because that's what we are doing. Lastly, your final step is to hit Solve. Okay, you will hit Solve. When you click Solve, this screen will pop up and it will say Solver found a solution. All constraints and optimality conditions are satisfied. It finds you a solution. Okay, for all of our homework, practice problems, and anything that we do together, if Solver is going to find a solution. So if you can't find a solution, or it's saying it can't find a solution, then you've input something wrong. Okay, there's always a solution in the examples that I will provide to you. Then we want our answer and our sensitivity reports, so we're going to click on both of those. And what will happen is then your answer and sensitivity reports will appear as new worksheets prior to the data sheet. So you're going to see answer report and sensitivity report for the data that you've input, and I will do that together with you real quick as well. All right, so we've got Microsoft Excel open. We are going to click on the button that says Solver. Okay, so Solver is popping up. Let me try and get it all to match my screen here. Okay, let's start with our objective function. Our objective function is D4. Okay, so you're just going to highlight cell D4. We want to make sure that it's set to maximize profit. So now we're going to go to our solution values. You are going to click on B8, drag over to C8. Then when you let go of the mouse, you will have those numbers input into there. Now we're going to do our constraints. So subject to constraints, let's add a constraint. Okay, so add constraint popped up. Let's add those constraints. You've got your left-hand side. Left-hand side is D5. It already says less than or equal to already, followed by your constraint of 240 hours for electronics. Okay, so now you're going to click Add. Don't click OK. And then now you can add your next constraint, which is assembly. So now you add D6. It's less than or equal to your constraint of 100. And now you can click OK. All right, so Solver Solver popped back up for me again. You can see now I've got my my decision variables in this section. I have my objective function up top, and then I have my constraints in this section. I have this button clicked to make sure that they are positive numbers. Typically, when you do the simplex method for the very first time, it's going to bring up GRG nonlinear. You do not want that. You want the simplex linear process or linear programming, so simplex LP, and then click Solve. So it says Solver found a solution. All constraints and optimality conditions are satisfied. So I'm going to click on Answer and Sensitivity Reports because that is what I want. I'm going to click OK. And now at the very bottom of the screen, hopefully you can see that I have an answer report and a sensitivity report. But one thing you'll also notice is the two decision variables. They were originally 0 and 0. They have now populated with 30 and 40. When I go to my answer report, okay, you can see when you created the report, and it gives you your answer, which is essentially your objective function is 410. Your solution values, so your decision variables, for X1 or XPods is 30, and for blueberries it is 40. Down at the very bottom you've got your constraints, which is 240 hours for electronics and 100 hours for assembly. We will go over what binding means in the next video, and then also slack and surplus, plus how to make sense of the sensitivity report, because there's a lot of useful data in here as well. So we have now completed the simplex method in Microsoft Excel. We've done that together, we've downloaded Solver, and we have solved the problem for Glickman Electronics. In our next video, what we'll do is we will go through the answer report and the sensitivity report, and we'll make sense of what those outputs are, and how when we change data, or we change our inputs, or we change some of our outputs, how it affects the sensitivity report and the model that we've created. So that's what we'll go over in the next couple of videos.